The space industry has been shocked by scientists' new dark matter discoveries. Hi everyone, welcome to our channel Space Light. 85% of the universe's matter is thought to be composed of atoms. One of the greatest mysteries in modern physics is the existence of dark matter, which has never been observed directly. According to specialists, dark matter is a crucial component in the development of galaxies, even though they do not know what it is. There is no way to observe dark matter because it doesn't radiate light, but scientists know it exists because there is a non-visible object in the galaxy. In other words, what precisely is dark matter and why are scientists so intent on finding out? Join us for a discussion on the recently solved riddle of dark matter. Let's get this party started right now. The gravitational attraction of dark matter is the only way to detect this mysterious substance. The amount of normal matter in the cosmos, including galaxies and stars, is dwarfed by a quarter according to astronomers. Although it may come as a shock to some, we have no idea what exactly makes up the cosmos. Don't worry, an Oxford scientist has offered a new idea that may end one of the greatest mysteries of the universe. Researchers have long believed that the cosmos will expand but eventually slow down. NASA's Hubble telescope discovered something strange when it began scanning the cosmos. There was no sign of a slowdown in the expansion of the cosmos. Astrophysicists couldn't explain why it was expanding at such a rapid rate. After a few experiments, this 95% of the cosmos is made up of dark matter and dark energy. For centuries, scientists have believed dark matter and dark energy to be different substances based on their influence on the objects we can see. An Oxford astrophysicist, Jimmy Fans, believes that a dark fluid with negative masses contains dark matter and dark energy. Negative gravity would therefore be present in the fluid. Instead of attracting objects, it would cause them to be pushed away. It's a novel idea, but it's not completely new. Many of the strange aspects of the universe are explained by Farn's theories published in the journal Astronomy and Astrophysics. If a galaxy spins fast enough to tear itself apart, it appears that the dark matter halo prevents this from happening. It's also possible that the negative mass dark fluid theory causes these halos. Even if dark energy does not become less dense over time, the presence of negative matter still poses a challenge because it signals that dark energy will become less dense with time. As a result, Farns employs the notion of matter production. More and more things constantly burst into existence and replenished negative matter that disappeared. A wonderful analogy for the model spacetime is that it behaves like popcorn with more negative masses popping into existence deliciously. In other words, the computer simulation and logic behind the black fluid theory are all it is. As a result, foreigners are wary of the findings and experts are correct to be skeptical on its face. According to General Lewis, professor of astrophysics at the University of Sydney, it can explain some of our universe's characteristics. Still, the question now is whether it can explain all of our observations. Before we can conclude this model is equivalent to our current understanding, we need to find out what predictions this model makes that the current cosmological model would fail to. Since the negative mass is an essential concern, it must be addressed first. Lewis says we don't know all the nitty-gritty details of how such a phenomenon can be created. The question is not whether or if we can formulate mathematical formulas for distinct phenomena, because we won't know for sure until we go out and test the universe. As he stated, researchers like those at the European Organization for Nuclear Research, CERT, are already looking into the possibility of negative masses, as hypothesized by Fans. Additionally, the construction of the world's largest radio telescope, known as the Square Kilometre Array, could aid in realizing Barnard's notion of extraterrestrial life. We must continually be pushing the boundaries of fundamental physics, added Lewis. Because every time we open up a new area, it seems esoteric and bizarre. Still, gradually it becomes a part of our existence. Furthermore, scientists have argued that the observable world is composed of protons, neutrons, and electrons packaged into atoms. In the 20th century, the discovery that ordinary baryonic matter makes up less than 5% of the universe's mass was possibly the most startling. Dark matter and dark energy are two unknown, invisible substances that appear to compose most of the cosmos. Due to its invisibility to light and other electromagnetic radiation, dark matter cannot be detected with current instruments. Still, scientists are confident it exists due to the gravitational effect it appears to have on galaxies and galaxy clusters, as previously mentioned. Dark matter does not interact with baryonic matter and is completely invisible to light. According to standard physics, for example, stars near the galactic center, where most of the galaxy's visible matter is concentrated, should move much more slowly than those at the galaxy's outer edges. However, observations show that stars orbit at about the same speed no matter where they are in the galactic disk. What appears to be a strange outcome can be explained if one considers that the galaxy's boundary stars are being affected gravitationally by an undetected mass of dark matter. Observations of optical illusions in the deep universe suggest the existence of dark matter as a possible explanation. It is possible that images of galaxies that show unusual ringing and arcing patterns are due to gravitational lensing, a process by which light from much farther away galaxies is distorted and magnified by enormous visible clouds of dark matter in the background. So far, scientists have a few theories about what dark matter could be. One popular theory holds that dark matter comprises exotic particles that do not interact with ordinary matter or light, but yet have a gravitational attraction. Other researchers believe that the impacts of dark matter could be explained by fundamentally altering our theories of gravity. There are many different kinds of gravity, and the large-scale gravity that governs galaxies is different from the gravity to which we're used. Even more enigmatic is dark energy, whose discovery in the 1990s stunned physicists. It was previously expected that gravitational attraction would slow down the expansion of the cosmos. Still, two separate studies proved that this was actually the case and that the deceleration rate was increasing rather than decreasing. An observer described it as throwing keys up in the air and expecting them to fall back down. Instead, they flew straight up towards the ceiling. Quantum fluctuations in otherwise spaces may be responsible for the universe's rapid expansion, according to scientists. What's more, as the universe expands, the force appears to be getting stronger. According to many physicists, a cosmological constant, a mathematical band-aid Einstein added to his theory of general relativity to make his equations fit with the idea of a static universe, is consistent with the known features of dark energy. According to Einstein, the constant is an anti-gravity force that prevents the universe from collapsing. The cosmological constant is Einstein's worst error. He eventually dropped it when astronomical observations showed the universe expanding. This is why bringing dark energy to the cosmological constant could almost explain how space-time is being pushed apart, but it still leaves scientists stumped. To understand why this weird force is present, we need to look at it differently, as this is pretty intriguing and complex, considering we're talking about perhaps something that not even human or mankind has even explored fully yet. For today, don't forget to subscribe to our channel, share, like, and comment. See you in the next video.